Now we're going to talk about integer operations and real numbers. Just as a reminder, what the order of operations deals with, the steps include do all the operations inside any grouping symbols first. So if there's any parentheses, do those first. Then number 2, do all multiplication and divisions in the order left to right. Then lastly, do all addition or subtraction in the order from left to right. Now, a mathematical phrase made up of numbers and operations is called a numerical expression. So you may hear the word numerical expression, and this is just talking about all of the numbers and the operations combined together. Okay, let's evaluate 18 minus 12 divided by -4 according to the order of operations. So first we have to do anything in parentheses. Well, it's just -4. Remember, we must do any multiplication division first. So 12 divided by -4 would give us -3. 18 minus -3, if we put it in absolute value, that would be 18 plus 3. 18 plus 3 is 21. Okay, I want you to go ahead and pause this and do practice 1 and practice 2. Okay, let's see how we did. Okay, so we want to go multiplication division left to right. So let's do 8 times 3 is 24. We're not going to touch the subtraction yet. So let's do -10 divided by 5, which would give us -2. So 24 minus -2, we can do our absolute value and turn that into a 2. So 24 plus 2 is 26. Okay, practice number 2. We have 5 minus 14 divided by 3 times 2 minus 6. We have to do everything within the parentheses first. So 2 minus 6, or 2 plus -6, is the same thing as -4. So we're doing what's in the parentheses first. And then we have 5 minus 14, which is the same thing as 5 plus -14, which is -9. Okay, so we have -9 divided by 3 times -4. The temptation is to do 3 times -4, but we have to work our way left to right. So -9 divided by 3 is -3. Then -3 divided by -4 would be 12. Now, integer operations with other grouping symbols. Now, grouping symbols also include fraction bars, exponents, square roots, and absolute value symbols. So let's take a look at this. We're going to first simplify this equation. We have to first look at symbols to do first. So let's take a look at the exponent. 4, and then you have the parentheses 7 minus 5. 7 minus 5 is 2, and that's the exponent 4 squared. So 7 minus 2 would be the exponent squared. And then we have 7 times 5 plus 1, and then we have absolute value 6 minus 9. 6 minus 9 will give us -3, but that's an absolute value, so that would turn into a 3. And then we have 5 plus 1, which would be 6. 6 times 7. So 4 squared would be 16. 7 times 6 is 42. And then we have the absolute value of -3, which would be 3. So now we have to focus on the division. 3 into 42. Then we can add 16. So 3 into 42 is 14. So 16 plus 14 is 30. Let's try another example. So here we have a square root symbol. 5 squared minus 3 squared in the square root symbol. So we have 25. 5 squared is 25 minus 3 squared, which is 9. And that gives us 16. 16 in the square root symbol would be 4. So 4 times 4 is 16. Plus -2 minus 4, or -2 plus -4, divided by absolute value of 8 minus 10. So let's go ahead, let's break this down. We're going to do the squared first. 5 squared, 3 squared, 25 minus 9. And then we have -2 minus 4, which would turn into -2 plus -4, divided by 8 plus -10. So 16, square root of 16, plus -6, divided by -2. So 8 minus 10 is -2. Now that absolute value of minus 2 becomes a 2. Square root of 16 is 4, plus minus 6 divided by 2. So we're going to have to do negative 2 do negative 6 divided by 2, which would give us negative 4. So 4 plus minus 3 would be 1. So negative 6 divided by 2 would be negative 3. So 4 plus minus 3, so 4 minus 3 would be 1. Now let's move into real numbers.
Please use this diagram to help you visualize what real numbers are. It shows a good separation between rational numbers and irrational numbers. It also identifies how natural numbers make up whole numbers, and whole numbers make up integers, and integers make up rational numbers. And as you can see, all natural numbers are whole numbers, but not all whole numbers are natural numbers. Not all integers are whole numbers. Not all integers are natural numbers. But natural numbers are part of whole numbers. Natural numbers are part of integers, and natural numbers are part of rational numbers. And then natural numbers are part of real numbers.
Now the picture on the right is a good illustration to show us what are real numbers. Real numbers include rational, integer, whole, and natural numbers. Those numbers are found within the realm of real numbers, but each of those are separate from each other. A rational number is a number that can be written as a ratio of two integers. So a rational number can be written as a fraction. Irrational numbers are non-repeating, non-terminating decimal numbers. So we did talk about this at the beginning of the year, where irrational numbers go on forever. Then we have rational and irrational numbers. Now, rational and irrational numbers combine to form real numbers. Here's an example. Each of the following numbers are real numbers, but they're all different types of real numbers. Go ahead and place each number at the appropriate place of the diagram to the right. So here we have square root of 13. The square root of 13 is not a rational, integer, whole number, or natural number. So the square root of 13 is a real number, but it would be outside of those separate four. 0 is a whole number. 4 is a natural number. 291 is a natural number. Negative 8 is an integer. 7.9 is a decimal, but it's ending, so that would be a rational number. That would be our fraction. Negative 14 is also an integer. 3 over 5 is a rational number, just like 7.9. Negative 3 2/3 is also a rational number. And then we have negative 2 square root of 5 would fall under a real number. It would not be part of rational, integer, whole, or natural number. So from that list, the natural numbers are 4 and 281. The whole numbers were 0. The integers, the negative 8 and negative 14. The rational numbers were the decimal and fractions, while the real numbers were the negative 3 2/3 and negative 2 square root of 5. All real numbers can be graphed on a number line. The points on the number line have a one-to-one correspondence with real numbers. All the properties studied earlier can be applied to real numbers. Let's see if you remember these properties. Let's see if you remember what these properties are. We learned these at the beginning of the year. Here's a little hint. Remember, associative, distributive, commutative. Let's see if you can identify these properties. Okay, pause this and let's see if you remembered any. Okay, letter A. 9 plus negative 5 plus 13. That blank would be 9. That's the associative property. B. That would be the 0 property of multiplication. C. We take A times B and then A times C. So AB plus AC, that's the distributive property. And then D is the inverse property of addition. And then E is the inverse property of multiplication. An inverse is the opposite. So the additive inverse is the opposite of a number. Additive inverses are two numbers whose sum is 0. The identity for addition. So A plus negative A equals 0. So those two opposites yield 0. Multiplicative inverses would basically be a reciprocal, or a multiplicative inverse are two numbers whose product is 1. So a times 1 over a yields 1. These are the multiplicative inverses. Here's an example. 29 times 1 over what equals 1? Remember, that's the reciprocal. The opposite, that would be 29.